two questions. One is, of course, if it does it mean that if an architect is to graduate and actually practice, uh, for example, if I'm a bachelor student right now, like if I'm in my first year or my second year, is it really necessary for me to put in the time and effort that it takes to learn a software like Revit, or can I really do without it? Is it absolutely necessary at this point, or is it still not there yet? Like if someone's like completely uninterested in BIM, is it necessary for an architect? Like if I'm to call myself an architect, is BIM something that's as necessary as a pen and pencil?
Not really, to be honest. And I'll start with that. Not really, because BIM as a concept is built on traditions of building that has to be prevalent. And that's what I think. Correct me if I'm wrong. It's just that, for example, people need to construct columns in a specific in a specific way for years so that it can become a tool in BIM as a column, right? Or so kind of BIM tells you what a column is supposed to work like. It's supposed to go from level 1 to level 2, right? It doesn't work any other way. For a window, you probably need there are hacks, but usually you need a wall to place a window inside. So that people need to construct windows for that with that specific way for years so that it can become an actual tool, like an automated tool. And that way you have no room for innovation. Like you have very little room for innovation, right? People have to do it for decades and it becomes a tool in BIM, or it becomes a new category in BIM. And then you have no room for speculation, not so much. With computation, it's different, right? Or with, whenever you're using ZBrush or just modeling, kit bashing with Rhino, it's different. You use things in ways that are not used usually, or you just let yourself go. You have this room to go free, right? You can go even free form completely. With BIM, you have to actually place things. You have to insert data, or you're bound by that data. And if you're going to be 3D printing a building, like if it's all sculptural, or you're doing something Gothic, it's it's not so easy to do it in Revit, right? Because it's not built that way. It's built upon the generations that came before you and how they did things and how they defined buildings. So if you want to do a new type of thing, any new thing, you have to do it in another platform for years and others have to do it for years. So it can become a viral technology of building things, and then it ends up in BIM. That's why I don't believe in BIM as a speculative tool. I believe in it as a very advanced practical tool that automates tasks. It makes things faster. It makes things way more accurate. It makes things less laborious, but it doesn't make, I mean, you have things like generative design, right? Like coming into Revit lately and things. But the thing is, also generative design have been used in design for the last 2-3 decades. And that's when after everything, it ended up in BIM as the way architects would use it in buildings. So it's the same case happening over and over. So yeah, for speculative and BIM don't go well together. It's like drones and snow.
I think there's a conversation to be had about what architecture you want to pursue, what kind of architecture you want to pursue. BIM is how we build stuff. It's a tool to actually build buildings. So to go back and answer your question, like, you'll pass, university without the need to learn BIM. Maybe I'm not sure, but it's for sure going to help you get a job after at a architecture practice where you're building buildings. My advice for students is to start with the computational side maybe first. Like for me, I was really interested in 3D. I started just I learned SketchUp at school, but then I learned 3D Max and got into the visualization side and all that kind of stuff. Then I got into Rhino then learning Grasshopper. I would always advise kind of Rhino and Grasshopper is, I would spend the time investing in learning Grasshopper first. But then, to be honest, having Revit, or sorry, BIM on your CV as a skill set does help you land a job. And having the combination of BIM and computation is becoming really, really valuable. So yeah, in university, you might feel like you're investing a lot of time that you're not getting a direct result out of immediately. But when you get to the real world, if you want to be a practicing architect, yeah, it's super, super useful for as a practicing architect. And that I think whenever you talk about BIM and computation, that there is it is about what kind of architect you want to be. And for me, I've always wanted to be an architect that's building things, and I've always been really interested in the technology side of architecture. Unfortunately, like the term parametricism and parametrics has come with it this like stigma of crazy geometry. And unfortunately, and like this was like stage one of computation, um, was like, now that exactly what you were saying, like now that we can make these things really quickly, like you can now make a spline, you can make these double curved surfaces, we're just going nuts, just creating like crazy buildings. And like when you say parametrics, you know exactly the image that pops to your head, and if you Google it, you'll see like all these crazy buildings. But at the same time, that's also kind of stinted or like stopped a lot of architects adopting it, especially at the more senior levels of a lot of these firms, because they see these tools of like, oh, it's not a crazy building, it doesn't need parametrics. I'm like, well, actually, there's more reason to use it because it's a simple building. And computation has allowed, or let's parametrics computation has allowed us architects to create these crazy buildings. But I think what's more interesting now, this like second generation of usage, let's say, is allowing us to become more efficient at what we're doing. And I think we're in this era of like, if you know, the world is screaming out for affordable housing. We need like to build more ecological buildings, more sustainable buildings. The construction industry is the one industry that's actually declined in efficiency over the last like 10 or 20 years, which is crazy, right? But then if you were to go to a conference on BIM and computation and stuff like that in like an architecture conference, you'd see all these crazy looking, we're making buildings even more complicated than they are. And there's definitely like this mismatch, and it's part of the reason why, unfortunately, like we're losing our credibility as architects. So I think there's these tools you can use in different ways depending on what you want to do. Like if your goal is to build as much as possible, then you want to be kind of in between that, kind of using it to create extravagant designs and using it to actually build stuff. If you want to be a bit more of an experimental architect, then yeah, these tools you can create stuff that you would not have been able to create before. And I think what was interesting, like you were talking about how using your computer as a slave, but also using your computer as a collaborator. That's when it gets super interesting to create things that you've never ever seen before. So yeah, I think like in practice, you look at, I'll swing back to like Big, for example. We're a relatively young firm compared to other big names, let's say. I think Big's around 20 years ish older at this point. I'm not sure. And but you look at how much we've built in that short amount of time, and part of the reason for that is a lot of the buildings are actually quite buildable and affordable to build in a way, because a lot of the principles that the classic kind of pixelated, it's not a style, but look, should I say, since is actually because it's quite buildable in that way. So there is, like, I think, going back to like what students should be learning, yes, I think they should definitely learn like computation and tools, but what's also missing is a little bit of like geometry and building technology. Like, it's fine to create really interesting and speculative geometry, but you've also got to start to learn like how to back it up with how you're going to build it, because that's when it becomes really interesting. We all architects want to build stuff, and so I think if you are, let's say you're a student, you're proposing something that's like very extravagant, but you say, hey, this can be 3D printed, and you've tested it on a little 3D printer and it works, and there's like an idea behind it, that's where it starts to become interesting. So yeah, I think as a student, definitely learn the computational side, and then see where that takes you. It might take you to like more of the visualization world, or the game engine world, or you could be still really interested in becoming a more practicing architect, and that's where BIM really comes into play, I guess.